Quadratic function models the height and feet of an object above the ground in terms of time and seconds after the object is launched off an elevated surface. The model indicates the object has an initial height 10 feet off the ground and reaches its maximum height 1,034 feet above the ground 8 seconds after being launched. Based on the model, was the height in feet of the object above the ground 10 seconds after being launched. So a really easy way to solve this problem is just to use Desmos, right? I know it's crazy. Desmos is so easy to use. The only problem here is you have to do a little extra thinking, right? It's because they don't give you all the coordinate points that you need. We do know a couple things. So we know that the initial height is 10 feet above the ground. So when x is 0, we're going to have a value of 10. So that's our first coordinate point. And they also give us the maximum value of 8 seconds after being launched. It is 1,034 feet. Now, the only problem with regression is that to use regression on Desmos, you need to have one extra coordinate point above your degree of the polynomial. So if I had a linear function, I could have 2 coordinate points and it would work. But since I have a quadratic, I need 3 coordinate points to make it work. Therefore, to find the last coordinate point, it's actually not that hard because you have to think about a quadratic function, right? If I have a quadratic function, I'm going to draw the other axis, and then the graph is going to look something like this, right? And what we know about quadratic function is that it's symmetrical, right? So if you were to think about this as 0, 10, right? And we think about the axis of symmetry as x equals 8, we know that everything is symmetric, right? So if this is x equals 0, and then this is x equals 8, then this value over here, when it returns back to the starting value, that has to be x equals 16, right? Because this is a change of 8, and this is also a change of 8. Side of the axis of symmetry is equal. Therefore, to find our other coordinate point, it's actually pretty simple because we know that this value, when it returns, has to have a y value of 10. And we already said that x is going to be 16. So we have 16, 10. We have our 3 coordinate points now, and now we just plug this into Desmos, as you can see here, just a table with the points, and we put in our regression, and it gives us our graph, right? It gives us the A, B, and C value. But the question is asking, what is the height and feet of the object above the ground 10 seconds after being launched? So since we already have the function that represents the problem, all we have to find is the value of the, what is this? The object, okay, the value of the object, or the height of the object 10 seconds after being launched when x equals 10, right? So we just put in x equals 10 here, found the intersection, we see that when x equals 10, the y value equals 970, therefore our answer is choice C. All right, so this problem says if 4a over b equals 6.7 and a over bn equals 26.8, what is the value of n? So to help us find the value of n, it'd be very helpful for us to scale up everything, right? Because we already know what 4a over b is, that's equivalent to 6.7, so we can use that to help us compare the values to ultimately find n. So if we were to scale up this entire equation by 4, we'd have 4a over bn, and then we would have to multiply 26.8 by 4, which gives us a value of 107.2. All right, so now it's just time to simplify, right? So what value of n would make this true? Well, because we don't actually know what the value of a or b is, we have to infer that based on our given information. We know 4a over b is 6.7, and we have 4a over b in our equation. So this simplifies out to just 6.7 over, and we have our n. So 6.7 over n is equivalent to 107.2. You can rearrange this to solve for n, and we would get a value of 6.7 over 107.2 equals n. And 6.7 over 107.2 also just simplifies to 1/16, and therefore our value of n is 1/16. Sample of a certain alloy has a total mass of 50 grams and is 50% silicon by mass. Okay. The sample was created by combining 2 pieces of different alloys. The first piece was 30% silicon by mass, and the second piece was 80% silicon by mass. was the mass in grams of the silicon in the second piece. So to solve this problem, we need to set up a system, right? So what we know now is that the first piece and the second piece make up this certain sample of alloy. And so what we can determine is that the total mass, this is pretty much the only information we're given in terms of actual mass, is that the total mass of the alloy is 50 grams. So we can write 50 equals, and now we need to create some variables. Let's create it as x and y. So what we want to define here is essentially x is just the mass, total mass, important to note, total mass of the first piece, and then y is the total mass of the second piece. But what we want to solve in the problem is the mass in grams of the silicon, only the silicon in the second piece. So how exactly do we do it? Well, we have to read in between the lines. It says that 50% of that 50 grams is silicon. So 50 divided by 2 is 25 grams. So we only have 25 grams of silicon in that sample. Therefore, we can set 25 equal to, well, what are our other given equations? Well, not equations, but variables. We have the first piece, which is 30% silicon by mass, right? So you know x is the total mass, and therefore now we only have 30% of that for silicon. So we got 0.3x, and now I'm going to do the same thing for the second piece, which is 80%. So 0.8 times the total mass. All right, so now that we've got these two systems of equations, we go over to Desmos and plug it in. So we can see, guys, we plugged it in here and we find the intersection. So this is our corresponding x and y values. It says what was the mass in grams of the silicon in the second piece. Remember, we labeled y as the second piece, the total mass of the second piece. And so the total mass of the second piece here is, you can see, 20. So 20 grams is the total mass. This is the total mass, not the silicon of the mass of the silicon, right? To find the mass of the silicon in the second piece, we need to multiply it by that 80% factor, right? Because only 80% of that 20 grams is actually silicon. So 20 multiplied by 0.8 gives us a grand total of 16 grams of silicon. Therefore, B is our answer. The table shows the results of a poll. A total of 803 voters selected at random were asked which candidate they would vote for in the upcoming election. According to the poll of 6,424 people vote in the election, by how many votes would Angel Cruz be expected to win? So these 803 voters are selected at random. So whatever results we get from them, we can pretty much scale them up or expect the same proportion or ratio as if it was 6,424 people. Therefore, what we want to do here is find the actual difference that Angel Cruz wins by. So 483 subtracted by 320 gives us a value of 163 votes. So now that we have this number of 163, we can't just use this number because that's only of the 803 voters. We need to scale it up, right? And to find the scale factor, we can just apply the comparison between 803 and 6,424. So 6,424 over 803 should give us that scale factor, and that's going to be around 8. All right, so if our scale factor is 8, we know that the Angel Cruz wins by 163 votes with just 803 voters. We need to scale this 463 up by 8 times as well. And 163 times 8 gives us a value of 1,304, and therefore our answer here is going to be B. Dot plots represent the distributions of values in dataset A and B. Which of the following statements must be true? So clause 1 says the median of dataset A is equal to the median of dataset B. And that's true because both distributions here you can see are symmetrical. If I were to draw a line down the middle, you have an equal number of points here and equal number of points on both sides, right? And so if you order the points from least to greatest and then you converge in the middle, you can see like on the ends, the 10 and the 16 cancel out, all the 11s and the 15s cancel out. You're always left in the middle with a value of 13. So let me just erase all that. So we know that the first clause here is true, so it can't be B and cannot be D. Let's see if the second clause is true. So it says the standard deviation of dataset A is equal to the standard deviation of dataset B. So here's the thing with symmetrical distributions, right? So when you got a symmetrical distribution, and you can calculate this if you don't remember this on the exam or something, is that when you have a symmetrical distribution, the mean and the median are the same, all right? They're equal. And so you can kind of see this in the points. So you got a value of 10 and 16. Because it's symmetrical, they should theoretically not cancel out, right? But you're going to get a mean of 13, right? 16 plus 10, what is that? 26. 26 divided by 2 is 13. We have 4 points in the 11 section and 4 points in the 15 section. If we were to zoom in on one of those pairs, you got 11 and 15. That's also 26 divided by 2 is 13. You can see how here all the points in the pairs come back to the mean of 13. We know the median is 13 and the mean also is 13 for these symmetrical distributions. Now, going back to standard deviation. Standard deviation is the measure of spread in a data. So the farther away a point is from the center, you know that it is going to have a greater standard deviation. And so because even though they're both symmetrical, right, data set A and data set B looks different, right? It has like more points at 15, or has the same number of points at 15 and 11, but only has 1 point at 13. Whereas data set A has a more condensed standard deviation here because of all those points at 13, and so their standard deviations cannot be the same, and therefore the correct answer here is going to be A1 only. Density of a certain type of wood is 353 kilograms per cubic meter. A sample of this type of wood is in the shape of a cube and has a mass of 345 kilograms. To the nearest hundredth of a meter, what is the length of one edge of this sample? All right, so as you know, density pretty much is the same regardless of how much you have of that material, right? So if we have a sample of this wood, the density of that wood is always going to be 353 kilograms per cubic meter. We know the equation for density is equivalent to mass over volume. And so if we are able to plug in values for density and mass, which we do have, we can solve for volume and ultimately find the length of one edge of the sample. So we know that density here is 353. I'm just going to ignore units. Mass here is 345 over V. If we solve for V here, we get V equals 0.977. So we know that the wood is in the shape of a cube, and so now we have the volume of that cube, right? And to find the length of one edge, we know that to find the volume of a cube, it's side length times width times height, right? And therefore, because we know that all sides are equal in a cube, we can just take the cube root of the volume to find one edge or side length. So the cube root of 0.977 is going to give us a value of around 0.99. Therefore, that lines up with our answer choice of B, and that is our answer. In the figure shown, lines R and S are parallel, and line M intersects both lines. So we got a parallel line cut by a transversal, so we want to be thinking about vertical angles, alternate interior angles, all that stuff. If Y is less than the value of 65, which of the following must be true? So let's just go right through it. So it says X has to be less than 115. So X is this angle right here. And because it says Y has to be less than 65, and which of the following must be true for all values of Y, we could just plug in a random value for Y. So let's just call Y 64 degrees, right? Because that satisfies that equation. And so now we know that this Y right here is 64 degrees. And so the angle opposite of that, that's going to be vertical angle. So this is also going to be 64 degrees. And we can see here that this 64 degree angle and angle X, these are consecutive interior angles. And so what happens is that they are supplementary. So they have to add up to 180 degrees. So you get 180 minus 64, which gives us, oops, that was real messy. Okay, 64 equals 116 degrees. So interesting note here is that 116 is greater than 115. So that does not add up with A, and therefore A is wrong. If we were to lower this angle, which we would have to, I mean, if we had like 64.99, we would end up getting what, like 115.0001, right? But let's see if B is true. So it says B says X has to be greater than 115. Is that true? Well, we know that the biggest value of y that we can have is 65. Or not even 65, because it can't even be equivalent to it. It would have to be like 64.999. And therefore, if we had 180 minus 64.999, etc., right? That would yield, what is that? 115.0000, etc., 1, right? That's messy, but you get the point. So basically, we can't ever go underneath 115 degrees for x if y is less than 65. Therefore, B is our answer, but let's just check the other answers to be sure. So it says x plus y has to be less than 180 degrees and x plus y has to be greater than 180 degrees. Well, we just proved it here, right? We said that if y, we could just name it 64 degrees. Vertical angles, this is 64 degrees. We find that x would have to be 116 degrees. 116 plus 64 is 180 degrees. And so neither C or D is correct because x plus y will always be equivalent to 180 degrees. In the given system of equations, r is a constant. If the system has no solution, what is the value of r? So I already done some of the work here because writing with a mouse is very hard. So we just arrange the top equation into slope-intercept form. So we get y equals 48x over 102 minus 24 over 102. And we compare that to the other equation, which is stated, ry equals 16 minus 16x. So this is important because we want to know the actual slopes, right? So our actual slope here is 48x over 102. And this one over here is negative 16x. And this is important because when you talk about a system with no solution, that means the lines don't intersect. And in a system of linear equations, the only way that those two lines don't intersect is if those lines are parallel, right? And how do you get parallel lines? Well, you need the exact same slope, but different y-intercepts. So we can see here that, yeah, they have different y-intercepts, but they need the same slope, which they currently don't have, but we can give them the same slope by changing r to the correct value. Another thing to note here is that negative 16x can be rewritten as negative 48x over 3, right? That's the exact same thing as negative 16x. And now we can see the direct comparison between negative 48x over 3 and 48x over 102. So from 3 to 102, what value is that? Well, that value is 34, right? So if we get the value of 34, we can actually convert the denominator of 3 to the value of 102. Another thing here is that r, we know now, has to be 34, right? Because if we divide both sides by 34 in order to isolate for y, dividing a fraction by 34 is the same thing as multiplying the denominator by that number. Another thing for r is that it will have to be negative. Why? Well, because this top slope is positive, right? But our current slope down here of negative 16x, that is negative, and that translated over here. We have negative 48x over 3 instead of a positive slope. And so if r is a negative number, that means ultimately when we multiply it into that denominator of 3, we're going to get a negative value in the denominator as well. A negative over a negative is a positive, and therefore we will get a positive slope there, which should work out. So let's just go right through. If we set r equal to negative 34, let's see what happens. So we get negative 48x divided by 3. So we're going to divide everything by negative 34. And that's the same thing as multiplying the denominator here by negative 34. So we'll get negative 48x over 3 times negative 34 is negative 102. So negative 102 or negative 48x over negative 102, like we said before, is the same thing as just 48x over 102. So we can see now that these slopes do line up, right? 48x over 102, 48x over 102. It's kind of messy, but you get the idea. The other thing we have to make sure here is that the y-intercepts are different, and they are vastly different, right? We got 1/6, and if we have a value of negative 34, that's the same thing as multiplying 6 by negative 34. That will give us a very small number, right? A much smaller number compared to 24 over 102. Now, that means that the value of r has to be negative 34. But that was such a long, complicated process, so there is an easier way. And that easier way is, of course, Desmos. All right, all you gotta do is plug the top equation in, plug the second equation in, have that R, have that R, set a slider for R, and just drag that point, right? Just drag this until those two lines are parallel, right? Until those two lines don't intersect, that is your value of R. That is the value of R that satisfies the equation when there is no solution. Which expression is equivalent to 42a over k plus 42ak, where k is a value greater than 0, and we get all these answer choices. All right, so what we're going to do here is pretty much just try and simplify this into its simplest form, essentially. So we get 42a. Oh, wait, actually, let me backtrack. So you get 42a over k, right? And we get 42ak over 1, let's say. And now what we can do is actually find the common denominator here. And the common denominator is very simple for this problem. It's just k, right? So this right here just stays as 42a over k because it already had k in it. And we want to add, and we're going to multiply this 1 by k, right? So we're multiplying both the numerator and denominator by k. So we get 42ak times k. And the reason we're doing that is to find a common denominator, and the k's here, k over k is 1, so it really is the same thing, right? It's the equivalent expression or form, but we just want a common denominator here because now that we have the same denominator, we can combine the numerators. We get 42a plus whatever over k. And so now we can see that k is going to be applied to this value. Now, be careful here, it's not distributive property. This 42ak, look at it as one term, right? One singular term. So this k can't be applied to the 42, can't be applied to the a, but can be applied to the k value. So now we get 42a k, and the k times the k is just k squared. All right, so now we need to factor out the greatest common value from the top. So that is going to be 42a, and 42a times 1 will give us this first value of 42a, and then plus k squared, which is going to give us 42a times k squared will give us the second value all over k. All right. So after doing that factoring, you realize that the answer choice that we got matches up distinctly with answer choice D. It's just flopped, right? This and this is flopped, but it is what it is because it's the equivalent form. Therefore, D is our answer. A salesperson's total earnings consists of a base salary X dollars per year plus a commissions earning of 11% of the total sales the salesperson makes during the year. All right, so let's just write this out. So the salesperson is going to make a base salary of X, and he's going to get on top of that 11%. So we'll just express this as 0.11 of the total sales. So the total sales, let's just call it S. Okay. So it says this year the salesperson has a goal for the total earnings. So this value right here, the total earnings, to be at least 3 times and at most 4 times the base salary. The base salary, remember, is the value X. Which of the following inequalities represents all possible values of total sales S in dollars the salesperson can make this year in order to meet that goal? So we just have to write our inequality out. So I'm actually just going to erase this and write our inequality. So we know that has to be at least 3 times the base salary. So 3x is less than or equal to our total earnings, and at most 4 times the base salary. So that's going to be less than or equal to 4x. All right, so now that we're looking at our answer choices, none of them actually line up, right? C is similar, right, with 3x and 4x, but it just has s in the middle, whereas we have x plus 0.11s. Therefore, in order to actually get an answer that matches up with one of the answer choices, we need to simplify this inequality. So here, very simple, we can just subtract x on all sides, and we end up getting 2x less than or equal to 0.11s
is less than or equal to 3x. And now again, we want to isolate for s because you see in all these answer choices, s is by itself in the middle as the total sales. Therefore, we can just divide all sides by 0.11. So we get 2x over 0.11 is less than or equal to s less than or equal to 3x over 0.11. And we can see that this answer choice right here lines up directly with answer choice B, and therefore that is our answer. So that does it for the video, guys. Make sure you check out our other SAT math prep videos, and I'll see you in the next